very simple, elegant experiments. Experiments that are very complicated usually doesn't end up enough. All right. Cellular genetic elements related to retrovirus. So there are cellular genetic elements that are relic to retrovirus or related. So we can establish a relationship, an evolutionary relationship between ourselves and retroviruses, which is really cool. Different from Mendelian patterns, right? It's not single traits that are going to be passed on, and you can do those cool Punnett squares and imagine what's the result's going to be. Genetic elements that move around like transposable elements, like the jumping genes. First found in corn, but then afterwards we found in ourselves. Can be used to insert the genes or inactivate undesirable ones. We can use this as a biotechnology too, right? The next step of medicine is going to be gene therapy. All right. How is this important for us? It's important in agriculture. Yes, it is. It is important in the field that I did research on antibiotic resistance. Yes, it is. And why is it important? Let me explain to you a little bit of the drug resistance with the transposable elements. So, there is something that you know, it's called lateral gene transfer, right? Horizontal gene transfer, AGT. So what is that? So we have, bacteria have the ability, right, to transfer genes from one bacteria to another. Usually, resistant genes shows up at first in the chromosome. So at first, they get a lucky mutation and they have a resistant gene in the chromosome. But very often, and it's quick, this gene gets out from the chromosome and they end up on the plasmid. Once this gene is in the chromosome and this bacteria and if this bacteria is capable of conjugation, this bacteria is referred as HFR. If this gene got out of the chromosome and ended up on the plasmid, this bacteria now is going to be referred as F'. Of course, this bacteria must be able to do conjugation. What do I mean by that? It must have the ability of forming a pili that will send its genetic material to the next bacteria. Now, who does this transfer? That is very, very important for the bacteria. Who transfers the resistant gene from the chromosome to the plasmid is transposable elements. So thanks to transposable elements, the bacteria is capable of doing so. And that increases bacteria antibiotic resistance exponentially, because while it's less likely to transfer this resistant gene to the next bacteria, to the recipient, if the resistant gene is in the chromosome, it's very easy to transfer a plasmid from one bacteria to the next. Very easy, because it's little. So the bacteria doesn't need to be connected for a long time. All right. So in this case, we have two classes of transposable elements. We have class 1, which is the insertional sequence with inverted repeat sequence flanking a transposase, which is an enzyme that's capable of leading the jumping, right? Creating the jumping, is able to cut and is able to paste, like integrase that we just saw. And they have drug resistance elements in between those two flanks of transposable elements. Why would they have drug resistance stuff? Could they have something else? Yes, they could. But why drug resistance then? Selective pressure, because if I take a gene that I really need, let's suppose it's a gene that gives me the ability of getting glucose in. If I take that gene out of its location, that gene might not work anymore and the cell might starve because it will not bring food in. Right? But drug resistance, the genes can be anywhere. It doesn't matter. It's actually a wonderful thing to end up on a plasmid. Okay? And I'll finish it right here, just 1 second. And then class 2, transposase plus resolvase to complete recombination. And then class 3, bacteriophages that insert its genome in random positions. Now you can ask yourself the question, who came first, the chicken or the egg? Really, that's really the beginning of the question. Would genes from our cells or bacteria cells become independent, or retrotransposons infected our cells? Think about this question. I'll see you on Monday.